In today's film, we will be talking about integer ratios. So integer ratios are ratios derived from integers, or in other words, just single numbers. So basically, the way the universe derives ratios, perfect ratios, is using only integers of addition and division. So in the graphs to follow, they will show how addition and division are used to derive all of the modalities in the universe, every possible combination in the form of a ratio, a wavelength, and an angle. You can also derive all of the other forces, but that's not going to be illustrated in today's videos. We'll just be focusing on those three. So as mentioned in previous videos, we spoke about the first three derivatives, the first three pyramid angles that can be derived using the baseline unit of 1. The map that will be shown is an automatic generation of all of the derivatives up to the number 7. So what's important to understand in looking at this map is that odd numbers are used to derive these values. And that's simply because of the law of octave. Even numbers duplicate again and again. So you end up with duplicated systems, which is not useful for this kind of work. So we're looking at the first derivatives. And the way that is achieved is by using odd numbers. Addition and division, that is the key. The baseline unit is the foundation for all of these equations. It is added together and it is divided. On the map that you see, the vertical column that is labeled Planck length number is addition, which is clearly illustrated. The horizontal column, which is division, is wavelength number. So this is the division, and the Planck length number is the addition. And I will go through step by step in how to calculate angle, wavelength, and ratio using the slides. So, in the second slide, I've eliminated all of the other modalities, just so that we can see the 1-to-1 ratio in the top left, which is unison. The 45-degree system, 401.21 nanometers, it has a ratio of 1. So the way this works is very simple. The first calculations we do will be to derive angle. So 1-to-1. 1-to-1 is unison. That is the number used to calculate angle, wavelength, and ratio. 1 being 45 degrees, because 1 is equivalent to 360 degrees. So 1 equals 360 degrees, and moving down in the addition column, 5. 1 times 5 equals 1800 degrees. Then we move to the division, which is 1 being 360 degrees times 5 equals 1800 degrees divided by 3 equals 600 degrees. So 360 degrees times 5 divided by 3 equals 600 degrees. And by the law of octave, this is halved until you find the value range of the pyramid. So 600 degrees, 150 degrees, 75 degrees equals the pyramid angle. Moving to the next slide, this is the calculation for ratio. So again, 1-to-1 is 1, 1 being the Planck length at the top left. So unison. So again, the same rule applies. We start with the first row, 1. Then 1 times 5 equals 5. 5 Planck lengths in the addition. Then we move to the division. Divided by 3 equals 1.66666. So 5 divided by 3 equals 1.6666. And that is how you derive the ratio for that modality. Now moving on to the wavelength. So we have 401.21 nanometers representing the 1 Planck length. Again, the same rule applies. 1 Planck length in color wavelength times 5 equals 2006.05 nanometers. Again, divided by 3 equals 668.68 nanometers. So 401.21 nanometers times 5 divided by 3 equals 668.68 nanometers. And this is the simple law for how to derive those three values: angle, wavelength, and ratio. This map represents all of the possible pyramid modalities that can be derived, up to the number 7. The map goes on for infinity, but ends up very shortly going to regions which make the map unuseful. This is quite simply because the wave number becomes too high and the power from source decreases due to that fact. In a later video, I will show a more extensive map which has modalities all the way up to the number 31 and many other various different pyramid systems within. This slide depicts the polygon by the revolution around the Planck length. So the revolution around the circumference of a circle being 1 Planck length, or the ratio, automatically generates these polygons. So the top left would be 1. 1 divided by 1 equals 1. So 1 revolution around the Planck length is 1 Planck length. Let's say if we take, again, the ratio of 5 divided by 3, that equates to 1.66666. And you can see where the ratio falls on a polygon. And you can see that these are the simplest polygons that derive these ratios and quite simply count up. Polygons become more complex as the ratio moves further away from the 1. You can see the transition between the equilateral triangle and the hexagon with the ratio of 5 divided by 3 and 7 divided by 3. This will keep fractalizing for infinity, but the simplest polygons, being the most universal, are the ones to appear first. And as you can see, the ratios fall perfectly on a point of each of the polygons until that polygon count is used up and each point is covered. So again, this represents 1 revolution around a circle plus the fraction. So for example, the ratio of 1 divided by 3 is 1 revolution around the Planck length plus 1/3, which makes the equilateral triangle. If we use the ratio 5 divided by 3, that is 1 revolution around the Planck length plus 2/3, which again forms the equilateral triangle. I hope you enjoyed.